Number 5, decide whether or not the functions are inverses of each other. Use the definition of inverses to determine whether f and g are inverses. And we've been given f of x equals 6x minus 7 and g of x equals x plus 6 over 7. And to determine if f and g are inverses, we're going to use the information from your textbook on page 387. And here it says, let f be a one-to-one function. So we've got to make sure that f is a one-to-one function. And if it is, then g is the inverse function of f if we do these two compositions. We'll compose f of g of x, see if we get x, and if we do, then we can proceed and compose g of f of x, see if we get x. And if both of these things are true, if after our composition we get x for both of these, then we do have, in fact, a situation where f and g are inverses. If, however, we're not able to simply simplify to x, then these two functions are not going to be one-to-one. But let's take this one step at a time. Let's go ahead and make sure that f is a one-to-one function. We can see f of x equals 6x minus 7. This is a basic linear equation, so we do know that it is one-to-one, but just for the sake of practice, let's make sure and verify that it's one-to-one using what we looked at earlier. I think it was question number 3, where we used f of a equals f of b. And to use f of a equals f of b, we've got to first find what f of a is, and then we have to find what f of b is. So using the f function, let's go ahead and find f of a first. And to do that, all we're going to do is take this original function. Anywhere we see an x, we're going to swap the x out for an a. So we'll end up with 6a minus 7, and there's f of a. Well, similarly, we're going to find f of b by taking our original function, and anywhere we see an x, swap in a b. So we'll have 6b minus 7. And now that we've found f of a and f of b, we're going to set these two things equal to each other, clean it up, and see if we end up with a equals b. So 6a minus 7 equals 6b minus 7. And again, we're going to do some work, and hopefully we end up with a equals b. But let's see what happens. And I'll get rid of that. So first things first, we can add 7 to both sides. That will get rid of our 7's, leaving us with 6a equals 6b. We can divide by 6 on both sides. And when we do that, our 6's go away, and indeed we are left with a equals b. So we know that the f function is one-to-one. So let's go ahead and proceed now to finding out if f and g are inverses. So again, we're going to compose f of g of x, meaning we're going to take the g function, so the g function, and we're going to plug it into the f function anywhere we see an x. All right, we're going to simplify, clean it up, and hopefully we end with just a simple x. If we do, then we can compose g of f of x, meaning take the f function and plug it into the g function, clean it up, and see if we get x. So let's see what happens. So I'm gonna come down here a little bit. So we're gonna find the f of g of x, again, meaning we're taking this x plus 6 over 7, plugging it in for x in the f function. So that will look like what? Well, 6. We're taking out the single x, just that basic x, plugging in the expression x plus 6 over 7 minus 7, and now we need to clean this up. So when we distribute this 6 through, we'll end up with 6x plus 36 over 7 minus 7. We're adding and subtracting fractions here, and when we add or subtract fractions, we need a common denominator. Well, right now, this is 7 over 1, and if we have a 7 and a 1, we know our common denominator will be 7. So we've got to multiply by 7 on both sides. I'll finish up over here. So when we do that, we'll end up with 6x plus 36 over 7 minus, and 7 times 7 is 49 over 1 times 7 is 7. Now that we have a common denominator, we can go ahead and combine these two terms here, and so we'll have 6x plus 36 minus 49. So we end up with 6x, and then 36 minus 49 gives us negative 13, all over that common denominator. And so you can see here that we're not able to get this to reduce or simplify to a single x. And so therefore we can stop at this point, because when we compose f of g of x, meaning when we take g, plug it into the f function and try to clean it up, we're not able to get a simple x. And so therefore f and g are not inverses of each other, and we can stop here. If, however, when we took g, plugged it into f, simplified, and we were able to get a simple x, then we would do the f into g, clean it up, see if we got just a basic x. And in that case, if you get x and x, you know that you have two inverse functions. But again, in this case, that's not what happens here. We end up with 6x minus 13 over 7. We can't do anything else with this. This is as simple as it gets. And so therefore, f and g are not inverses of each other.